All right, welcome to the second midterm review session, and let's talk about the elephant in the room, which are Laplace transforms. And in particular, let's try to solve the differential equation y prime minus 3y equals 6f of t with initial condition 2, where f is this jump function that's 0 until 4 and then jumps to e of t minus 4. And of course, the first step, as usual, is to take Laplace transforms. So take the L, and of course, you would have to take Laplace transform of f, but for this, notice that f is a jump function because you start at 0, and then at t equals 4, you jump by e of t minus 4. So f is just e of t minus 4, u4 of t, which literally follows from the definition of u4 of t, because it's either 0 or 1. Yeah. And now we have our ODE, y prime minus 3y equals 6f of t. And now let's take Laplace transforms. L of y prime minus 3L of y is 6 L of f of t, which is L of e of t minus 4, u4 of t. And remember, we have a shift and jump, and whenever you have that, an extra exponential term appears. So what we get, SL of y, of course, minus y of 0, minus 3 L of y, now becomes 6 e of minus 4s, again, because of shift and jump, and we're shifting which function? The exponential function, LE to the t. So here, once again, let me write this on a new line. Note, we used a property we talked about before, namely, if you take the Laplace transform of shift and jump, f of t minus c, uc of t, extra exponential term comes out. So e of minus cs of the unshifted Laplace transform. All right, and then if you do that, you get, well, SL of y, and then I think y of 0 was just 2, minus 3L of y is 6 e of minus 4s. Laplace of e of t is 1 over s minus 1. And then you can factor out L of y. So I think s minus 3, L of y, then becomes, put the 2 on the right-hand side. So 2 plus 6 e of minus 4s times 1 over s minus 1. And then L of y dividing by s minus 3 becomes 2 over s minus 3 plus 6 times s minus 1 times s minus 3, e of minus 4s. And again, careful, the e of minus 4s is just on the 6 over s minus 1 times s minus 3. Now, this 2 over s minus 3 is already a Laplace transform, which we'll talk about. So let's now focus on this partial fractions term. So the next step is to do partial fractions. So let's look at this. So 6 over s minus 1 times s minus 3. You split it up as a over s minus 1 plus b over s minus 3. And let me do this because I haven't done partial fractions in a while. So this is a times s minus 3 plus b times s minus 1 over s minus 1 times s minus 3. and that is just AS minus 3A plus BS minus B over the same thing. And then you factor out the S. So it's A plus B S plus minus 3A minus B over the whole thing. And remember, this is 6, which is 0S plus 6 over the same thing. And then we just need to compare the coefficients. So A plus B is 0, and minus 3A minus B is 6. Equals 0, and then minus 3A, which minus 3A minus B is 6. And then you can solve this using B equals minus A, and you eventually end up getting A is minus 3, and then B is 3. And so really what this tells you is 6 over S minus 1 times S minus 3, that is minus 3 times S minus 1 plus 3 over S minus 3. Very good. And now let's go back to our differential equation. So far we had L of y equals 2 over S minus 3 plus 6 over S minus 1 times S minus 3. So minus 3 over S minus 1 plus 3 over S minus 3. And times the exponential term, E of minus 4S. Now let's write everything in terms of Laplace transforms. So let's L of 2e to the 3t, and then plus L, I think for minus 3e to the t plus 3e to the 3t, and then E of minus 4s. And now remember, if you put an exponential term inside, it gives you a shift and jump. And so what this gives us is L of 2e to the 3t plus minus 3e to the, I think, t minus 4 plus 3 e to the 3 t minus 4. And then u4 of t. Again, if you want to put an exponential term inside, it will shift and jump. And that's it, because now we have our solution. So y of t becomes 2e to the 3t, and then plus minus 3 e to the t minus 4 plus 3 e to the 3 t minus 4 u4 of t. Let's box this. And then we're done. So the whole point is Laplace transforms, you can really do it for any constant coefficient ODE. It doesn't even need to be second order. It could be first order as well.